In network theory, there are two philosophies widely employed for solving a network. First one is the mesh analysis, and mesh analysis is using the principle of Kirchhoff's voltage law. And the second one is nodal analysis. Nodal analysis uses the principle of Kirchhoff's current law. So if we are aware of how we are applying both the Kirchhoff's current and voltage laws, then solving a network is very much easy. So first of all, let us consider the KVL approach or the Kirchhoff's voltage law approach for solving a network, which is otherwise called mesh analysis. Okay. First of all, what is a mesh? Let us consider a problem, and I will explain the mesh with respect to this problem. So here we have to find the current through the 4 ohm resistor. Okay. So first of all, let me define what is a mesh. A mesh is defined as a loop which does not contain any other loop within it. So for example, or simply what we can say is a mesh is a closed path in a network. So this is a mesh. Okay, and here this is another mesh, and this is another mesh which forms a closed path. Okay, and you can consider an outer mesh like this. Again, this is also a closed path. Okay, so independently there are three meshes in this circuit. There are three meshes in this circuit. So before going into mesh analysis, let us consider the various steps involved uh, or the various steps to be followed in mesh analysis. The first step is identify the mesh. Mesh means a closed path in a circuit. Identify the mesh and assign a direction to it, and assign an unknown currents in each mesh. Okay, that is the first step. And the second step is assign polarity of voltages across the branches, okay, or across the mesh. Then apply KVL around the meshes using Ohm's law and obtain the mesh equations. And the last step is solve the equations for unknown mesh currents. So if we follow these steps in a uh, step by step manner, okay, we can easily find out the solution for the network. So now let us consider this network. So first of all, I am assigning the current. Say this current is I1. Okay, mesh currents. Identify this is one mesh. So I am identified this mesh, and I have assigned a current direction. Okay, say this current is I1, and this is another closed path, another mesh. So I am assigning this mesh with current I2. Okay, and I am assigning this mesh with current I3. Okay, now the second step is you apply polarities for each mesh. Apply polarities for each mesh. Here I have drawn this circuit for clarity, and the polarities in each mesh is given with a separate color. So for mesh 1 I have used a pink color, for mesh 2 I have used a red color, and for mesh 3 I have used a green color. So here the basic principles we have to know, the basic principles only. So we know that suppose we consider a resistor like this. Okay, resistor like this, and this polarity is V1. The potential at this point is V1, and the potential at this point is V2. Okay, suppose V1 is greater than V2. V1 is greater than V2. V1 is greater than V2. In that case, the current will be flowing from higher potential to lower potential. Okay, current always flows from flows from a higher potential, a higher potential, a higher potential to a lower potential. We can consider current flow similar to a water flow. Okay, current flow is similar to, you can consider current flow similar to a water flow, a water flow. Okay, when suppose this current is flowing like this R, okay, so sorry, the resistor is R and the current is I, and the potential is, when the current flows from flows in this direction, there is always a decrease in potential. Decrease in potential in the sense, this potential is positive because V1 is at higher potential and this potential is negative. So when the current is flowing along a resistor, there is always a decrease in potential along the direction of current, because along the direction of current the potential decreases. Okay, because here there is a positive potential and here there is a negative potential, and along the direction of current you can see that the potential decreases from positive to negative. Okay, there is a decrease in potential. So while writing Kirchhoff's voltage law, you have to note down the polarity of the voltage, where whether it is an increase in potential or there is a decrease in potential. So here in this case you can see that the potential increases, and since the current is I1 current is flowing through this resistor, there is a decrease in potential. Okay, so I have written here positive and written here negative, and here also in mesh 1, if you are considering the mesh 1 along the direction of current I1, here there is a decrease in potential in the 2 ohm resistor. Okay, and similarly here also there is a decrease in potential. Okay, so when you apply Kirchhoff's voltage law in the first mesh, what will be the equation? The equation will be, okay, let us consider the first mesh. The equation will be, here there is an increase in potential. Increase in potential is taken as, that is the fundamental rule. Increase in potential is taken as positive, whereas decrease in potential is taken as negative. Increase in potential is taken as positive and decrease in potential is taken as negative. So that is the sign convention. So if you apply the KVL along the first mesh, that is using Ohm's law, that is the step 3, apply KVL along the mesh using Ohm's law. So here there is an increase in potential, so this is 8 minus I1 into 2, because I1 is the current and 2 ohm is the resistor. So current into resistor will give you the voltage. Since all the terms are voltage, we need not write the voltage symbol here as a unit, because every term in a KVL is definitely a voltage. Okay, and here along this 2 ohm resistor, okay, the pink color, the polarity is, there is a decrease in potential along the direction of I1. So it is minus, the resistor value is 2, but here there are two currents. We are considering I1, we are moving along the direction of I1, so I1 is taken as positive, and here there is an I2 which is flowing opposite to the direction of I1. Okay, so I2 is taken as negative. So minus 2 into I1 minus I2. Similarly, is the case with this 2 ohm resistor. So along the direction of I1, if we consider mesh 1, here there is a decrease in potential in this 2 ohm resistor. So the polarity is negative, decrease in potential. The resistor value is 2, and the current we are considering is a positive current, which is I1, and opposite to that I1 there is the current I3 flowing, so through the resistor 2 ohm. So minus 2 into I1 minus 2 into I1 minus I3. Okay, and this is equal to, and this is equal to, this is equal to 0. This is equal to 0. Is it okay? So 8 minus 2I1 minus 2 into I1 minus I2 minus 2 into I1 minus I3 is equal to 0. Okay, now if you rearrange this equation, you will be getting 6I1 minus 2I2 minus 2I2 minus 2I3 is equal to 8, and this will be your equation number 1. While solving the mesh 1, you will be getting an equation like this. Okay, and now let us consider the mesh 2. Mesh 2. I have already given the polarity of the elements in mesh 2. So along the direction of current through a resistor, there is always a decrease in polarity. So the polarity is marked here plus and minus. And here it is plus and minus, decrease in potential in red color. Okay, and here there is a battery. The battery is positive here and negative here. So along the direction of current, there is a decrease in potential. And in the 2 ohm resistor, along the direction of I2, here there is a decrease in potential. Okay, so I have marked plus and minus here. Okay, so now we can apply Kirchhoff's voltage law for the second mesh. So when I apply Kirchhoff voltage law in the second mesh, so here let us start from this point. Let me start from this point. So in the clockwise direction from this point, so the resistance is 2 ohm. The resistance is 2 ohm. Since there is a decrease in potential, I have put a negative sign here, minus, and the current is I2. So it is minus 2I2, minus 2I2, and here in the 4 ohm resistor along the direction of I2 there is a decrease in potential, so minus the resistor value is 4, and the current considered is I2 in that mesh, and the opposite current is I3. In the 4 ohm resistor the opposite current flowing is I3, so it is given a negative sign, so it is I2 minus I3, I2 minus I3. And now coming to the voltage source, here there is a decrease in potential, so again minus, decrease in potential is given by a minus sign, and the polarity of the battery is 6. Okay, and again considering this 2 ohm resistor along the direction of I2 there is a decrease in potential, so it is minus 2 into, now the current is the mesh the mesh 2 we are considering, so the current is I2 which is taken as positive, and opposite to the current, opposite to I2 there is a current I1, so it is taken as negative. So this is I1 and this is equal to, the sum is equal to 0. So we have considered the second mesh. So the direction of the second mesh is considered clockwise like this, and along the resistor, along the direction of current, the potential in the resistance is decreasing, so the polarity is given like this polarity and this polarity. Along the direction of current, the potential is decreasing in a resistor. Here we are considering the current direction as I2, so along the current direction the potential is decreasing. Okay, and since through the 4 ohm resistor and this 2 ohm resistor there is another current which is flowing the opposite direction. Okay, and the opposite current is taken as negative. That is why here we have taken minus I3 and here we have taken minus I1. Okay, so that is equation number 2. So if we rearrange this equation, what we will be getting is, we will be getting minus 2I1 minus 2i1 plus 8i2 minus 4i3 is equal to minus 6. So this is equation number 2. So we have solved for the second mesh. So the second mesh equation is minus 2i1 plus 8i2 minus 4i3 is equal to minus 6, and this is equation number 2. And now we have to solve for one more mesh, and actually that is the third mesh. And while writing KVL along the third mesh, what will be the equation? Along the third mesh? Okay, so let me uh, delete that, and now here I am writing the equation for the third mesh. So this is the case with first one. Okay, first one. This is the case with second one, and now I am writing the third mesh equation here. So first of all, you assign the current direction. This is I3. Okay, and the second point is you assign polarity to each element. So along the direction of I3, here there is an increase in potential, and when I3 flows through this resistor 4 ohm, there is a decrease in potential. So it is marked as a decrease in potential in green color here. So here also there is a decrease in potential. Along 2 ohm also there is a decrease in potential. And now let me start from this point. So, and now you apply KVL along this mesh. So 6 volt increase in potential. So it is taken as 6 along the direction of current through the resistor. Voltage always drops or decreases. So minus, the resistor value is 4 and the current is I3. So it is minus 4i3. Okay, and here also minus, potential decreases. So minus, the resistor value is 2 and the current is I3, minus 2i3. And here this 2 ohm resistor, along the direction of I3 there is a decrease in potential. So it is minus 2 into, but there are two currents. I3 is along the direction. So I3 is taken as positive. We are considering the direction as I3 here. So I3 is taken as positive. And opposite to I3, we have I1. So this is minus I1. And now there are no other terms. So the sum will be equal to 0. So this is 6 minus 4 into, no, sorry, here there are two currents. So here there are two currents, 4 into I3 minus I2. Okay, രണ്ട് current ഉണ്ട് ഇവിടെ. Here there are two currents. So here 4 into I3 minus I2. 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 Then here there is only one current, minus 2 into I3. Here also there are two currents, so minus 2 into I3 minus I1 is equal to 0. Okay. Now if you rearrange this equation, what you will be getting is, you will be getting minus 2 into I1 minus 2I1 minus 4I2 plus 8i3 is equal to 6, and this is equation number 3. Which is nothing but minus 2i1 minus 4i2 minus 4i2 plus 8i3 plus 8i3 is equal to 6. This is equation number 3. And now you have three equations in three unknowns. The three unknowns are I1, I2 and I3. Okay. And now you can solve for these three equations to get I1, I2 and I3. Since there are three meshes, we have three equations. If you have two meshes, you will be having two equations. Okay. So this is how we are solving a simple problem using mesh analysis. So again, let me recap what we have done here. We have given a problem like this. So first step is we have to find out how many meshes are there. We have found out the meshes. There are three independent meshes. Okay, and we assign the current directions. So I have assumed this I1, I2 and I3. Any values you can give, or you can suppose you can take this as I1, this is I2 and this is I3, but I have followed in this fashion I1, I2 and I3. And the next step is you assign polarity for each element. So the thing what you have to remember is along the direction of current in a resistor, there is always a decrease in potential, and current always flows from higher potential to lower potential, similar to a water flow. Okay, so similarly here the potential is like this, minus, plus, minus and plus here, and here there is a decrease in potential because current is flowing in this direction. Okay, current is flowing in this direction, so there is a decrease in potential. So the decrease in potential is given by plus and minus like this. Okay, and the polarities are given. Okay, for each mesh we have given the polarity. For each mesh we have given the polarity, and it depends upon the current direction, because since I1 is taken as clockwise direction, here it is positive and here it is negative. Here it is positive and here it is negative. And here I2 again in the clockwise direction, so here it is positive and negative here, plus minus along the direction of I2. And in mesh 3 also, along the direction of I3, we have considered the polarity, which is along the resistor, the potential always decreases. And we have written the Kirchhoff's voltage law. Okay, and we got three equations, and now the rest of the job is to solve these three equations for the three unknowns. So you can solve these three equations using any of the techniques that you have studied in your mathematics courses. Okay, so that is how we are solving this network. Now let me consider another one network. Okay, let it be this network. Okay, this is similar to a bridge circuit. Okay, a bridge circuit, and we want to find the current supplied by the battery, and this is the problem that what we have to do. Okay, this is the problem what we have to do. So first of all, let me assign the current direction. Okay, and let me consider the meshes. Here we can consider that how many meshes are there. I can consider this as one closed path, and this as another one closed path, and this as another one closed path. So there are three independent meshes. Say this is the first mesh. I am considering this as I1. Okay, and let me consider the polarity of that mesh also. So the current is flowing in clockwise direction. So here there is a decrease in potential. Again, here there is a decrease in potential. Here also there will be a decrease in potential. And here already the polarity is given. There is an increase in potential. So we have done the polarities with the first mesh. Okay. And now let us consider the second mesh. I am considering the current in this direction. Okay, say this is I2. Okay, and now I am starting from this point. Let me start from this point. The current is flowing in the clockwise direction, so there is a decrease in potential like this. So plus and minus. So in this mesh, the current is flowing in this direction. So here it is plus and minus. So for this 1 ohm resistor, considering I2, the potential is plus and minus. So The polarity with I2 is done. And now let me consider the third mesh. Okay, the third mesh. Let me start from this point. So this is the third mesh, and this is the current is I3. So along the direction of I3 in the 5 ohm resistor, there is a decrease in potential. Okay, here also there is a decrease in potential, and here also there will be a decrease in potential. So all the polarities are marked. Okay, now I have to consider the current equations, or sorry, the current equation in the mesh 1. Okay, so that we have to write the KVL along the mesh 1. So let me apply KVL to the first mesh. So it is, here there is an increase in potential, so it is 4, and decrease in potential minus I1 into 3, minus I1 into 3, and here minus 1 into the resistor is 1, and the current we have considered is I1, so I1 is taken as positive, and the opposite current is I2, so it is given minus I2, minus I2. And here considering 4 ohm, there is a decrease in potential, so it is minus 4, and the considering current is I1, so it is taken as positive in the mesh 1. So the opposite current is the I3, so it is taken as negative, so minus I3 is equal to 0, is equal to 0. Okay, so 4 minus 3I1 minus 1 into I1 minus I2 minus 4 into I1 minus I3 is equal to 0. Now, if you rearrange this equation, what you will be getting is, you will be getting 8I1 minus I2, 8I1 minus I2 minus 4I3, minus 4I3 is equal to, is equal to 4, is equal to 4. So this will be the equation number 1. That's all. Okay. Now we can consider, the Kirchhoff's voltage law applied in mesh, in mesh 2. Okay, in mesh 2. So there are only 3 elements. So now let me write the equation here. So let me start from this point A. Okay, A, B, C and A. A, B, C and A. I'm considering this path. So along this 2 ohm resistor, there is only one current. So it is minus 2 into I2, decrease in potential. Okay, minus 2 into I2. And now in this next element is this 5 ohm. So definitely minus 5 into the considering current is I2. LA. Considering current in the mesh 2 is I2, and the opposite current is I3. So this is opposite current is I3. Minus 5 into I2 minus I3. And here next is the 1 ohm resistor. So definitely along the direction of I2 there is a decrease in potential. So it is minus 1 into the current in mesh 2 is, considering mesh is I2, and the current in the other mesh which is flowing in the opposite direction is I1, minus I1, and this sum is equal to 0, and this sum is equal to 0. So it is minus 2I2 minus 5 into I2 minus I3. Okay, minus 1 into I2 minus I1 is equal to 0. Okay, now if you rearrange this equation, what you will be getting is, you will be getting equation number 2 as minus I1, okay, plus 8I2 plus 8I2 minus 5I3 is equal to 0, and this is equation number 2. And now the next job is only we have to find the KVL equation for the mesh 3. Okay, for the mesh 3. So let us do that. So CB, let this point is D, CBD. We are considering the point CBD. C, C, B, D, C. This path, C, B, D, and C. Okay. So the current in the mesh is I3. So we are moving along the direction of I3. So the opposite current should be, so the considering current is I3 and the opposite current in this case is there is only one, there is two opposite currents. When we are moving along the 5 ohm resistor, the opposite current is I2. So it should be taken as negative. And here, while moving along the direction of I3, the opposite current in the 4 ohm resistor is I1. So I1 should be taken as negative and I3 should be taken as positive. And that is the only thing we have to consider. Okay. So now let us start from this point CB. So the considering current is I3 and the resistor is 5. So there is a decrease in potential along the direction of I3. So minus 5 into I3 minus the opposite current is I2. Minus 5 into I3 minus I2. And here there are no other currents, only I3. So there is a decrease in potential and the resistor value is 6 and the current value is I3. The current value is I3. Okay. And now coming to DC. DC, we are moving along the direction of I3. So there is a decrease in potential. So it is minus into 4, the resistor value, and the current is considering current minus opposite current. Opposite current is I1. Opposite current is I1. And this is equal to 0. This is equal to 0. Okay. This is equal to 0. So it is minus 5 into I3 minus I2, minus 5 into I3 minus I2, minus 6 I3, minus 4 into I3 minus I1 is equal to 0. Now, you rearrange this equation, so you will be getting the third equation. The third equation is minus 4 into I1, minus 4 into I1, minus 5 I2, minus 5 I2, plus 15 I3, plus 15 I3 is equal to 0. Plus 15 I3 is equal to 0. So this is the third equation. Now you have three equations in three unknowns. You can solve for these three equations. Okay, so this is the first equation. This is the second equation. And this is the third equation. Okay, and you can solve for these three equations for three unknowns, so that you will be getting the currents. You will be getting currents as I1 is equal to 0.66 ampere, I2 is equal to 0.24 ampere, and I3 is equal to 0.26 ampere. So that is the solution. With this, so that is the solution with this network. Okay. .26 ampere. Okay. And now let me give the solution for the first problem that we have seen. The problem. So the solution for this problem is I1 is equal to 2 ampere. Okay. I1 is equal to 2 ampere. Okay. I2 is equal to 0.5 ampere. I2 is equal to 0.5 ampere. I2 is equal to 0.5 ampere. And I3 is equal to 1.5 ampere. 1.5 ampere. So this is the case with Kirchhoff's voltage law approach for solving a network. Specifically, the mesh analysis of solving a network. Now let us consider some special cases. Suppose you have a problem like this. Find the current through the 5 ohm resistor. You are asked to find out the current through the 5 ohm resistor. Okay. Okay. Here you can, the first thing is you can assign the current direction. Okay. How many meshes are there? There are 4 meshes. Okay. 4 meshes are there. So I am considering this as the first mesh. So this is I1. And this as the second mesh, I2. This as the third mesh, I3. And this as the fourth mesh, I4. Okay. So if we inspect onto these meshes, for meshes I1, I2 and I4, the current is already given. The only thing is you should consider the direction of current. If the assumed direction of the mesh current and the direction of the current source is same, you can take it as positive. And if it is opposite, you can take it as negative. That's all. If the assumed direction, if the assumed current direction, if the assumed current direction and the direction of current of the current source, of the current source, of the current source are same, current source are same, take it as positive, take it as positive, positive. Otherwise negative, otherwise negative. This is the only thing what we have to keep in mind. So if that is the case, what about I1? I1 is equal to I1 എത്ര വരും അല്ലെ I1 ഉം 4 ആംപിയറിന്റെ കറണ്ട് ഡയറക്ഷനും both are same. So I1 is equal to 4 ampere. I1 is equal to 4 ampere. And I2 we are taking it as clockwise direction, like clockwise direction. So I2 is equal to 3 ampere, the same as that of the current direction of the current source. I2 is equal to 3 ampere. And I4 we have taken in the clockwise direction, but the current direction of the current source is opposite to that. So you can take it as negative. So I4 is equal to minus 3 ampere. Minus 3 ampere. So you have already 3 currents. The unknown current is the current of I3. For that, you apply Kirchhoff's voltage law in this loop. You apply Kirchhoff's voltage law in this loop. In mesh 3, you apply Kirchhoff's voltage law. How will you apply Kirchhoff's voltage law? In that mesh, suppose I am starting from this point. Okay. So the current is I3. So minus 2 into I3 minus I2. So that is done. I3 is the considering current and I2 is the opposite current. So I3 minus I2. And here the considering current in the 2 ohm resistor is I3. So again minus 2 into I3, considering current minus opposite current, minus I4. I3 minus I4. And now coming to the battery, along the direction of current there is a decrease in potential. So it is minus 2 volt. Again coming to the 5 ohm resistor, minus 5 into I3 minus I1. Minus 5 into I3 minus I1. All the elements are done. So this is equal to 0. So this is equal to 0. So you have all the values. I1, I2 and I4 here. Substitute the value of I1, I4 and I2. You will be getting the value of I3. So I hope these problems are clear to you, and these are the various cases that you may come across while solving a network using Kirchhoff's voltage law. Okay, Kirchhoff's voltage law. And I hope you have understood these problems. Okay, thank you.